before we start today, I'll just mention a couple of things. The first thing is that during February sometime I will have this evaluation. And there will be 3 evaluations of this course during the semester. And for that we need 3 to 4 people who can hopefully volunteer to give us feedback. That's very useful for us. If it's something we would like us to do better, something we would like to see happening in the course, we will try to do what we can to satisfy that, as long as within the boundary of reason. So anybody who will volunteer, if you're interested, okay, great, nice. Then we need 2 to 3 more. Okay, then we have 3. That's very nice. Could you send me an email with your name, and then I will list you on the wiki as a reference group, and then later on we'll try to find a slot during February, probably towards the end of February. We can just have some feedback meeting, and then another one in March and another in April, most likely. Great. The other thing, you have now started to work a little bit on the labs. You can find someone you would like to collaborate with on the first assignment. That will be mentioned or we start to introduce that in a couple of weeks' time about. So you can start to think about who you would like to collaborate with. So 2 to 3 people per group on the assignments. So we can get back to that later, but try to figure out someone you would like to collaborate with to join groups. Okay?
Okay. So 15 is about right, and we have 2 liars in the room as well. So that's nice. Anyway, yeah, this is probably good because that means there's a little bit of a demand for this lecture at least. We are going to talk a little bit about debugging on the CPU side, so C++, and then we're going to touch a little bit on graphics debugging as well, now that you have started. The reason we have this lecture pretty early is because in previous years there has been some complaints that this lecture was after the first assignment, and people were like, "Oh, you can do this," or "Oh, fuck, I wanted to. How you could have solved this issue a lot easier, So that's one reason we're going to have it a bit earlier. So even though it's not, everything might be clear because you haven't worked too much with this, like OpenGL yet, I don't know how much you have actually worked like on your own. Yeah, so this will be like a few tips and tricks. I'm going to ask you some questions, and we're going to look at some code, like where you can try to identify the mistakes or where there could be potential for mistake. And if you find it, that's great. And if not, we're going to look at why it's bad and why what can go wrong. So you have to save you some trouble. And when we come to the graphics debugging, we're just going to look at some examples and tools that you can use. I'm going to show one tool, which is very helpful and helped me a lot. That will also hopefully help you guys a lot when it comes to figuring out what is wrong and looking at exactly how data flows between the CPU and the GPU. So before we go on, we are going to have one more question. Yeah, that's 15. So it is a bit of a trick question because both of them can be hard, and definitely since we're doing graphics, it can be a little bit harder and more challenging, especially since it's going to be a very different sort of mindset. And it's not just, you're not going to have access to all the variables, so you can't just print all the stuff that's on your graphics card. That's not going to work. So you need to rely on debugging tools, or writing correct code in the first place, but that's not going to be so easy in the learning process. But yeah, both of them can be hard, but they're definitely harder together. So let's jump into a couple of the first examples. Most of you guys are probably on Windows and use Visual Studio, I would expect. But so what I show you here is going to be in VS Code. But the hotkeys and how you work with it is more or less exactly the same when we do the debugging. And apart from that, it's just identifying potentials for bugs. And when we go to the graphics part, all of the hotkeys are also still going to be exactly the same, even though the UI is slightly different. Everything applies as much in Visual Studio as in whatever other IDE you might be using. So let's change the font size. Yeah, I think I have it here. Great. Good?
Yes.
Yeah, that's one nice. And we gotta zoom one more time. So last time we briefly mentioned data structures such as vector and map that you can use. We're going to look at a couple of bugs that you can that can surprise you or screw you over when using them. So I don't know if you actually tried to play around with it a little bit, but we're going to look at some bugs associated with that right now. So so you can like avoid doing them on your assignments, and just so you're aware of that they exist. So some of them are a bit like tricky, but it will save you some headache potentially if you decide to use them. If you don't use them, then that's on you anyway. So let's look at the first one. So we have a map from string to integer, or in Python it would be a dictionary, or a hash map, whatever you use. It's a map structure. So we have a string and map it to an integer, and we say map bracket hello equals 25, and then we see out map hello. Any ideas what is going to happen here?
There is no key with hello, so there won't be a value.
Okay. Other opinions or thoughts? So yeah, this is a bit weird. One, because in some languages this would crash your program because it doesn't exist. But yes, you're correct. In C++, this will actually just produce a default value and also insert hello to the map, which means your map now consists of hello, which is equal to 25, and your map also consists of hello, which is equal to 0. So by printing this, you have now inserted an element to the map. So, which is not exactly obvious, but that's the way the square brackets work on the map. So if you're using the map, make sure either you spell this correctly, or if not, there's another method you can use, which is called map.at. This will not insert if the key does not exist. So if you try to use map hello here, it is instead going to crash instead of inserting a shadow, a key that you don't know. So for example, if you use this, for example, for key bindings, like you have a string mapped to a glfw key, and suddenly somebody enters the key H, and that doesn't exist in your map, this is going to prevent them from inserting the key H and randomly binding it to any key. And instead make sure that, well, this will throw an exception, so it will crash your program, but you can work around that by either catching it, or you can upfront use one of the other algorithms we looked at last week to check basically, does the key in the map, does the key hello exist? And if it does exist, then you can use it, otherwise you will not use it. So be aware of using the operator square brackets on map. And another way we can check this to see the behavior is if we go into main, we just call it potential bug 1. If I just run this program, so we just go run. Oh god, that was small. No. Can you see it? Yeah, it prints 0 basically. So there's no error as we talked about. However, we don't. If you didn't know about this, you would maybe be a little bit surprised that this is happening. So what we can do, and this counts for Visual Studio Code, most IDEs. If you click in the sidebar, you can set something that's called a breakpoint. And have you heard about breakpoints before? Yes, good, nice. So basically what this lets us do is that when the code runs and we get to this line, everything is going to stop and pause, and you can like look at the state of your program at that current line. And from there we can like go through, run the program line by line to see exactly what happens and what changes as each line is executed. So in this case, we might want to figure out why is this printing 0. So we're going to run it with the debugger. So in Visual Studio, you just hit F5 for this, and it's going to run it with the debugger instead of Control F5, which is the regular hotkey to run it without the debugger. So basically, we get now a list of our variables in here. In Visual Studio, you would I think you get it on the right side, but you will get, or in the bottom probably. Anyway, you're going to get your list of variables at some point. And what we can do with that is we can now look at the map. And if we use the keys up here, so these are the same for all debuggers. You usually have a continue, which just keeps running until the next breakpoint. You have a step over, which is steps over the line and goes to the next one. You have step into, which goes into the function. So if you're calling a function on this line, which we are calling the map constructor, is going to go into that function, and so you can keep debugging inside of it. And then there's a step out, which basically takes you out of your current scope. So since we are in this function, it's just going to take us back up the main. And that's how you can, that's the tools you have in all debuggers for navigating the code, or restart, which just starts over the program. So if we, and the hotkeys here are the same as in Visual Studio, so it's F10 to skip to the next line, F11 to go into a function, and Shift 11 to go out of a function. So if we just go to the next line here, we can see, hopefully, if it's going to let us, it's not going to let us. Well, that sucks. Well, no, yeah, because it's empty. Now we can see that as we went past this line, the map now contains hello, which has the value 25. And if we hit F10 one more time, oh, looks like the debugger didn't work. Let's actually run it in the other program. It's more like Visual Studio, I would say. So let's do the same, click to set the breakpoint, and run it. So now we have the map up here instead, basically. I think it's not easier to see, but sorry about the font size, I don't think I can change it. But again, when we go to the next line and the next one, we see now that map has to have 2 items, and it's hello and hello. So you can, by stepping through the code, you realize that this is actually inserting something as well. But let's go to the next bug. And later we have one that's a little bit more interesting to step through. So so potential bug 2. It's a function that takes a vector by reference and returns an integer, and it's a vector of integers. So by doing this, what can be bad about this? Yeah.
The vector doesn't necessarily have that many.
Exactly. You have no idea how big this vector is. You're just like randomly choosing 5 or 10, and relying upon that the vector has a certain size up front is generally not a good idea. So since a vector can change its size, unlike an array, it would have a fixed type size. Like if this was an integer array, it would be it would generally contain, for example, 5 items, and you would know that it had 5 items, or even better, if you used the stud array, you would know that it had 5 elements. But with a vector, you don't know how many elements it has at the current time without checking it first. So again, you have 2 options. You should always range check your vector if you're going to access an element and rely on an index being there. So by doing that, you would go vector size is greater or equal to 10. So at this point, if it's not that, or basically you can flip the logic as well, if it's less than 10, then we want to return some error and not use the vector at all. So that's one way of avoiding it. And the other one is just to use, instead of the brackets, you also have the at function, which will throw an error if it will do a range check. So if you run it with at all the time, it will do a range check first, so it will be a little bit slower. But when you're debugging, it can be nice to have the range checks there, just to be sure that you're not introducing a random bug by indexing out of the bounds of the vector. So that's just a little quick one. Now we're going to look at an OpenGL related issue, but one that's on the CPU side. So let's close this. Zoom out. So based on what you have done so far, well, it might not be obvious what the issue is, but there are actually 2 issues in this code. Yes?
One of them is that you're passing the data by value, not by reference.
Where?
The vertex data.data.
Okay. Another one? It's a bit less obvious, I would say. But, so when we're creating this buffer and assigning it here, and then we're doing buffer data at the target that's supposed to be bound at array buffer, do you remember that this buffer has not been bound yet? So when we are calling buffer data, it does not know it doesn't actually write it to any sort of buffer. So because when we created the buffer, we have to also bind the buffer, which is the VBO, before we can write it. And we have to specify, actually the other way around, VBO. So when we use GL buffer data, it expects a buffer to be bound to that target. So do not forget to bind the buffer you're working with before you're passing over the data to it. Unless you use its counterpart function, which is GL named buffer data, in which case you can pass the VBO directly and you don't have to bind it first. It will write it directly to the buffer. So those are basically your options to avoid this. The other error is actually not this one, it's this parameter, which is why it's not so obvious. Since vertex data.size returns, yeah?
It's actually giving it the length, right?
Yeah.
And we need the sizing in bytes.
Exactly. So when you're using vectors with vertices, or vector in general, calling .size, as you say, gives you the length of the buffer and length of this array and not the size in bytes. So a simple fix you would think would be to just go size of vertex data, like you would do with an array. Would this work? Based on your knowledge of the size of operator. Well, it actually shows you here what it produces. Produces 24. Is this do you think these values are 24 bytes? Or more or less? Yeah, definitely. So what the size of does is that actually, in this case, gives you the size of the vector as a type itself, because the vector holds 3 pointers, one to the beginning, one to the end, and one to the how much it can hold maximum. So basically now you're getting the size of the vector type, not of all of what it contains. So in order to use this with a vector, you need to remember to add vertex data dot multiply the size of the vector, not the size of the vector, but this vector's first element, by the side length of the vector. Or in this case, if it's empty, that would also crash you. So it's better to type size, say size of vertex. So, which is the type the vector is holding. So that basically the size of the type multiplied by how many of them there are. So keep that in mind when you're working with vectors and this function. Vertex data actually just returns a pointer to the first element in the array, so that's basically converting it from a vector to something OpenGL can understand, just like you would in C when you have a C-style array. There you would just pass the array itself, but vertex data the data member function of a vector basically just gives you a pointer to the first element, so it becomes like a C array. So keep that in mind. The size of error can be a huge pain with GL when you're passing things, and we're going to look at an actual example afterwards. So, next one is just a little bit of example and exercise with manipulating with the debugger itself. So we're going to pull it back out. This function does nothing useful. There are a couple of bugs in here. Let's try to see if we can find them without the debugger first. It's going to be easier with it. Let's see if we can get all of it. So this is the function. Just take a minute to read through the unnecessary complexity of this one and see if there's one issue that pops up. It's one bug in there, really, but
does unsigned just stand for unsigned integer?
where?
The data type unsigned.
Yeah.
Does it just stand for unsigned integer?
Yeah, basically. Yeah. It's the same as doing this.
On the for loops, we're defining yet, but we're checking the I, right?
Yeah. Oh, here?
Is that I?
Yes, that's really J. You're right. That was a non-intentional one. Good one. That's why you do code review. But yeah, you're right that it's the bug is likely to have something to do with unsigned and the for loops, but finding out which one can be a bit tricky.
Yeah, we're the first time it's 0, we're taking -2 from 0 and making it a negative number.
Here?
Yeah.
Yeah.
No. There.
Yeah.
We
Yes.
have yet equal to 0.
Yeah.
But we cannot subtract from there could be an issue.
Yeah. You
Because
could go below
we can
0.
Go below 0.
Exactly. Yeah. So what about this loop? Will this one go ever end based on the same logic?
Yeah, no, because it's always going to be bigger.
Yeah. Because when this one goes to 0, it's going to minus one more time and wrap around an underflow. So it's going to be the highest possible unsigned number. So if you have bigger functions like this, and there's a subtle bug maybe with unsigns and counting backwards in a loop, or it could be anything else, but the point is the same. So now we're going to try to find it. We can first do it without the breakpoint at all, as long as we remember to call it complexity 3. So we just run it, and we're going to see that it prints zeros forever. So what you can do, even if you launch the program with a breakpoint, but you don't have any breakpoints, if you click the pause button, which is going to be in any debugger, it will show you exactly what line it is on at this point in time. So basically now we can see that this program is actually stuck in here. And if we use F10 just to step to the next line a couple of times, we will see that, okay, I suddenly is a really huge number, and we can see that temp is also a huge number. And based on this, we should catch that I should never be this high. So we have two options. We can go back and set a breakpoint on the line before, and then just run it again. Then we can see, once we start, that I is 6, and we can see what's happening. So it goes down to 5, and it goes down to 4, and so on. And now it's at 0. So the intention for this code was to make it stop at 0. But once we go here, we see that it actually wraps around. So you can catch what's happening by looking at all the values. And if this could be some other, obviously this is a very fabricated scenario, but the idea is to get used to the habit of not just printing thing, because if you were going to do that, instead you would have to make sure you would have to print something at every line. We should use this. And you have to recompile, and then you have to go back inside. You maybe have to add a print statement for every single variable. But when you run it like this, you will be able to see all the variables and their current values that are currently in the local scope, or you can also look at globals. You can also, for example, right-click on, well, that's not all debuggers support that, but you can add watches to things. So for example, let's do that in here. Let's open it and go back to the exact same function and set the exact same breakpoint. So now we come here and we can see those same variables. We can see data, which is the input parameter. We can see temp, which is the one we're plussing to. And we can see the current loop variable. So what we can do is this would be the same also in Visual Studio. If you right-click either an expression, so for example you can right-click just this variable, or you can right-click an entire line, and you can add an expression evaluator in Visual Studio. It's called add watch. Oh, that one doesn't work, but it works for this one. And then you will get a special line. You will get also in Visual Studio a separate window which holds all of those variables that you right-click to say you want to watch them. So no matter where you are, it's going to try to show you this value. So this can be interesting if you got a global, or well, if you have a global. Or if you have some other variable that's a member of a class that you really want to keep track of, that can be screwing you over. And that way you will be able to pay attention to it no matter where you are. So if you really want to look at temp, you can extract it by adding a watch or expression evaluator or something similar. Or if you have an if statement, for example, let's add one in here. If data is greater than 5. So if we set the breakpoint there, setting breakpoints as well, the hotkey for that in Visual Studio is F9, so if you want to set one quickly, it's just F9 and you're going to see it pop on and off. So if we come here, we can drag all across this entire thing and add an expression evaluator to that. And then we can look at it live, like what is data is greater than 5, and we can see the result of the entire expression live. So now it's false. And if we pass something else into this function, you can see that it's true. So being able to look at those variables and being able to have the entire data structure available to you while stepping through line by line to see exactly where things go wrong is a very powerful tool. So, but let's we are going to go over to the graphics part, but maybe we'll have a little bit of a break before. Like maybe until 1 p.m. Yeah. And then if there's any questions, you can ask them as well.